Thank you everybody for swinging in. I guess we will go ahead and get started. This is a talk on advanced Int-Bigint migration, conversion, and all that other fun stuff. I do have a little bit of introductory stuff in here, and we'll get into that in a second. Just as an overview, I'm curious how many of you have actually had like a production outage because of this problem? Okay. So, and the rest of you are just like, we want to see how the other side lives, and it's not good, so there you go. All right, so quick introduction. I am at RobTreat2 on Twitter. I am RobTreat in real life, and you can email me at robtreat@instacluster.com. I'm supposed to say we do Postgres stuff, manage data platforms, we make it all go good. All the Postgres, that's us. And we're hiring, so come talk to me about that afterwards. I would definitely love to hire you. Ground rules for the talk: it is okay to ask questions. Please raise your hand if you want to ask a question. If I don't call on you, it's probably because I didn't see you. If I call on you, I may not answer your question, so just don't get too offended. We'll see how it goes. Slides will be online at some point. This is the first version of the talk, so if you need something specific, and you might, because there is a little bit of code in here, and it is not exactly easy to write down, I will definitely make that available to you. And feel free to take notes. Again, I will put the slides online, but science, if you believe in that kind of thing, says you'll remember it better if you take notes, so I won't get offended if you try to write it all down, even though the slides will be online. Also, I should put a warning in, and this is a general rule, that whenever I do give out code, I like to make sure that it doesn't actually work the way that I've given it out, so that when somebody comes back later and says, like, I tried your code and like it totally screwed up my database, I can be like, I know it wasn't my code, you must have changed something, because it would have just given you an error. All the code you're gonna see here is based on bad notes that I've took or gone back and looked at, like PSQL, scroll back or whatever, that I've cobbled together from actual production outages that I've had to deal with, mostly in real time when people are screaming because they're losing, millions of dollars by the second or whatever. So, like I said, don't expect it to work, but it should give you most of what you need. It'll get you 90% of the way there, and hopefully get you thinking about some of the options that you may have. So, TLDR, your mileage may vary. So I'll do a little bit of overview just so we all understand sort of the scope of the problem, how it tends to come up in ways you might not be thinking about. This will go pretty quick, but if you have questions, feel free, like I said, just stop and ask, and I'm happy to go through it a little bit more. So this is the problem. All right. No, there's more to it than that. So basically, this is the thing that you're probably looking for, and if you see this like in your logs in production, somebody comes to you, on Slack or something, and says, "Hey, I got this integer out of range error. What does that mean?" And you can pray that it's going to mean that they tried to put like some weird epoch-based date into a date field, and if that's what they did, then you're probably okay. And if it's actually like the value is like 2.14 billion something something, like then be concerned, because now you have a bigger problem that's probably going to be painful. We tend to get into this, from what I've seen, there's what I call the Goldilocks and the three data types issue. In Postgres, there are three basic things. There's other ones like float and numeric, but basically people will look at these three data types to figure out how they want to store numbers. The first one is small int, stores up to 32,000. Most people look at that and they say 32,000 rows, that's probably not big enough. I probably need something bigger. And I'm not going to use small int. They might look at big int, and they'll go look at that one and say, that is a big number. 9 with lots of things after it, I don't even know. I think that's probably too big. And then they look at integer, and they're like, it's 4 bytes. It's like 2 billion. 2 billion ought to be enough for anybody. I'll go with this one. It's just right. And so we pick integers as the default. And when I say we, that often can be DBAs who are designing schema, but it is often also like ORMs that are being designed to generate schema, or other tooling like that. So this is usually what people settle on as the integer space, with the idea that 2 billion is enough for anyone. And sometimes they're right. The other part that you need to know about when you get into this, and again, this goes back to the data types and whatnot, is for a long time we've had this pseudo type called serial within Postgres. And when people say, I need like some auto-incrementing column, right, auto-generated, it's going to stick the number in there so I can have, primary key column on my table. We tell people, use a serial data type. That'll do it for you. It creates a sequence behind the scenes, starts filling in those numbers, and by default, that is an integer-based sequence and column. right? So people will use that, and they get started, and they start putting their data in. It's all good. There is another type called big serial. So if you think you're going to have a table that's going to exceed 2 billion, use big serial. But people usually don't learn that until after they hit one of these integer overflow problems in production. But be aware that that does exist, and you can use that. So that's an option. Just a lot of people don't. And again, ORMs and code generation tools typically don't do that. They just use the serial type. There's also a new thing called identity, because I figure somebody might say, what about identity columns? Well, okay, you could use identity. It does potentially leave you open to the same problems. When you define an identity column, right, you have the name, you have to pick a data type, so you got to pick the right one. Now we're back to the Goldilocks issue. You probably pick integers, right? And then it will go ahead and still do all the sequence stuff behind the scenes, so that will be set up for you. So it's nice and convenient, but again, if you guess the data type wrong, you think 2 billion's enough and it ends up not being, like you're still back in trouble. And we'll come back to that a little bit later. There's some things I'll show you here in a minute to talk a little bit more about that. But just sort of understand that, right? Like we're doing some schema generation, and basically we end up picking an integer column, goes to 2 billion, we think that's enough. However we get there, and then it's not so much. And I'm going to say, like, yes, in case anyone wants to talk about whether, natural primary keys are better than surrogate primary keys, or whether we should be using UUIDs for everything. Those are great discussions to have. Lunch is right after this talk, and that's a good place to have them with other people. We're not going to talk about that here. I only mention 8 because I know that those are other options, and I like to try to be, 97% complete. So we're not going to talk about that too much more. The other thing I really want you to keep in mind, and this I think gets lost in all these discussions because we usually focus on the technical side of this, but when you have this problem, there are some characteristics to how this usually unfolds, right? So usually it tends to be surprising. Like you suddenly just hit this error message that comes up. You've been inserting away for a long time, and suddenly you're out of space, and oh my God, what do I do, right? I got to do something quickly. Again, many times it's taking you years to get there. You do some basic math, if we ever get, 1 million users, and every user, maybe they do 20 orders, that's 20 million rows. It's going to take 10 years to get to 2 billion. And that conversation will be had probably about 3 years before this happens. And then the DBAs will quit about 2.5 years, right, into that 3-year period. And now it's your problem. So, right, you might be there and you're the one facing this and you're like, why did they pick that number? It seems obviously too small. Institutional knowledge will not exist. You've got to figure it out. And again, if we're talking about a table that is exceeding this, it's probably over the 2 billion mark, so there's a likelihood you may have, at least 1 billion rows in that table, if not 2, because it corresponds to the number. So once you have 2 billion rows of anything, it doesn't have to be a very big table. It still is a lot of data that you actually have to work with, especially if you're on a production system, right? So keep that in mind, that when you're in this scenario, people will be under stress. It can be very stressful for folks to work through. Even if you catch it early, and we'll talk about that in a second, it can still be pretty stressful because you have sort of this countdown timer, right, before things go bad. So some people say okay, well, we'll just put some monitoring in place and then we won't have this problem, right? If it's all stressful and it's really bad and it can take years to happen, we probably should be able to monitor this and not ever actually fall, prey to this problem. And this is that's a fine thought to have. This requires that you use the Int-Bigint column type where it's needed, right? And again, because this is usually surprising, we're all bad at guessing the future. Our best bet was probably I'll learn Postgres and that'll probably be around for a while. And we've made that bet pretty successfully. But if we were really good at predicting the future, especially with numbers, we'd probably have won the lotto, and then we'd be funding somebody else to do our conference talks instead of doing them ourselves. And that didn't happen. So here we are. Again, there's other cases like bugs in ORMs. If any of you here use Django, Django for a long time had a bug in its ORM where you would declare the primary key as a serial, or you would declare it as a big serial. It would create the column as an integer column, and then create the sequence with the idea that it was going to go up to the Int-Bigint key space, right? So the sequence looked good. If you looked at the sequence, it seemed like it was going to be fine, but the actual data type in the table was still integer. So not good. And if you didn't realize that is what had happened, eventually you get surprised. Also, there's an issue of artificial escalation that can happen. I've seen this case, and there's different versions of this, but if you imagine, let's say you get to 800 million users or something, probably not even that big. If you're in the 10 million to 20 million range, you're going to get to 100 million. People might start saying well, maybe we should shard the data or try to do some kind of nifty thing or split it up on different servers. And what we'll do is we'll just divide the space by 10 and then use that on each server, right? So now suddenly, instead of going from incrementally one at a time, somebody starts up at 900 or 1.9 billion or whatever, right? And now they've only got 100 million rows left before they go because they're on that server where we just start everybody at 1.9 billion. Again, that's an easy decision to make from a design perspective if you're architecting the thing, but you've got to go look at the data types to see if you can support that or how long it's going to be before you can't, right? So you just watch out for those kinds of issues that can creep up. Even if you are good at guessing, other people are probably involved and they might undo what you're hoping for. The other option that people often say is well, we should just use Bigint for everything, right? Anytime we're going to use a number, we don't use small ints, we don't use integers, we just use Bigint for everything. I would push back on that maybe a little bit. It will take more space, right? You're going from a 4-byte column to an 8-bit. It's not actually bytes and bits. That was a slip. But as you understand, right, you're doubling your space that you're going to need. And whether that's disk space, index space is usually a bigger one that's an issue, especially the more indexes you have and the more places that might be used. It is more RAM, it's more swap. These things are measurable. I don't know that I would say they are actually that significant. I usually sort of get the impression that once you're talking about billions of rows, this difference might just kind of come out in the wash, that you already probably, you're going to be dealing with terabyte-sized tables and whatnot, so this one table that's really big, if it is one table, maybe it's going to make that big of a difference, or you are going to figure out how to do sharding or splitting up your data on multiple systems or whatever. So I don't know that I would say don't do that, but it isn't common practice, and one of the big pushbacks is usually because of the amount of extra space and RAM and whatnot, resources that get used. I will say there are other databases, that is actually how they solve this problem in the sense of solving it. CockroachDB is a common one. If you use an integer type in there, it is an 8-bit under the hood, just like the Bigint, so they just map it all to the same thing. And so they don't have to deal with this problem, even though it looks very much like Postgres. If you use the same syntax between the two, be careful, because in Postgres you might hit this problem, and in Cockroach you wouldn't. So the nature of that database, for those that aren't familiar with it, it's based on the Postgres wire protocol, but it's underneath the hood, it's a distributed database across multiple systems. So I think they don't have the same concerns, right, about RAM and disk storage and that, because you just add more nodes and Amazon gets happier. So again, we could use Uuid primary keys, right? I mentioned that before, but I'm not going to talk about that. There are reasons not to use that, but that's a different talk. I think maybe Magnus has a blog post on that. I don't know. I've seen them out there. Go Google that. Like I said, I'm not going to debate it. If you did use Uuid primary keys, you wouldn't have this problem, but you'll have different ones. So trade-offs. All right, so if we can't stop the problem a priori, I'm sure we can monitor the problem away, right? We can't avoid it, but we can find it. But here's the thing. So this is a fallacy that we have, that monitoring and testing are ways that we can stop production outages. It really is just not true. I see people recommend this type of thing all the time. We work in complex distributed systems, right? By definition, if you're working on Postgres and you have clients connected to it, you're on a distributed system. Postgres is not a simple tool, right? It's got a lot of options and features and whatever that you can use. It is complex. The more applications you have that start talking to your database, the worse it gets from a complexity standpoint. So the idea that you're just gonna I'm gonna put a monitor in place and I'll never have this problem is not really true. That doesn't mean you shouldn't try to monitor for these problems. I'm just saying, take it with a grain of salt. So the most common thing that people usually do is they say well, I'm gonna look for the max value of all my IDs in my tables, right? And if I just run that across every table, then I'll know whether or not one of them gets to the breaking point, right? I'll know before it gets to the breaking point. And you can build an alert on that, if you're using Nagios or whatever. When it gets to 1 billion, let me know. And that's, it's probably fine to do that because all your ID columns, if they're the primary key, they should have an index. It'd be weird if it didn't. So that is probably fine for one narrow class of what the problem could be. But then if you start thinking about like foreign keys, right? So like maybe that column is referenced in multiple tables elsewhere. Do you have indexes on all those foreign keys? Like Postgres doesn't build those by default. So usually if you're not querying directly on those foreign keys, you might never index those columns. I wouldn't. But now if I'm going to set up like automated checking to try to do that, I will have to build those indexes. That might lead to more disk space usage than I want just for monitoring purposes. It gets complicated. Again, real world issues, right? Like other things that we find when you try to sort of automate that thing where we're just going to query across these columns. If you're talking about billions of rows in your system, what we find is people often drop the foreign keys for like performance or contention reasons. And so then like actually trying to find where is the parent and where are the children can be much more difficult because there's no actual definition of that. So you start like trying to do some guessing based on column names, see if you get that correctly. Doesn't account for things like integer arrays. We've had cases of that where like, I'm gonna have like, 3 delivery IDs or something on this row, and I'll put that in as an integer array. And so then if you get enough deliveries in your system, right, like it'll blow up. Doesn't account for externally referenced IDs. So like maybe you have a vendor ID column, which you're getting from some external source, and that is an integer, or you think it is. And so you put that as an integer type. You've got to know that might, grow faster than you expected. Or even just like, just normal integer columns that are not part of a foreign key. Like you can have them for other things. So that's also possible. So I came up with this query that you can use to actually figure this out. And this is actually relatively cheap. And this is the one that's probably hard to write down. And I'll walk you through it a little bit because the real important part is, again, this is like just to give you an idea of like you could get this data, and it took me a while to work this out, so figured I should share. So basically what I'm trying to do is, the overall idea is I'm going to look in the PG stats tables that we have, right? So you run analyze on your database, you run analyze on your tables. We create histograms of the data that's in your table, right, for all those columns that are in there, whether they're integer columns or whatnot. So here, like in this query, right, at the very top, right, I'm just grabbing, like, give me all the things that are integer, bigint, int array. You can put in whatever data types you want to look for. But in our case, we're mostly concerned about integers, but maybe we want to look at integer arrays. Right, then we grab the min and the max value from the histogram buckets. So those are usually spaced pretty evenly within the table. So we get the low range and the high range, right, that we've collected from our analyze. That's over here. And it's really kind of messy because the way that data is stored in the table, it looks like an array that would be very simple to work with, and it's not. So you see like there's some futzing in here to like convert it and unwrap the array and then rewrap the array to get the min and max values. Here, the first one is for integer arrays, and the one that's down here is just for integers. So I didn't actually grab the one for bigint. If you want to look at that, you can, right? You would add another section like this in there. Or if you know you don't have integer arrays, you can take that out. You could, in theory, expand that to other things. A lot of people ask me about like Json columns, whether they should be concerned. The nature of JSON generally means you don't have to be, but like it's not going to cause an error in the JSON itself. It might using it externally, but for purposes of trying to monitor this, it's not usually a thing. But that's what these two columns are, and again, like it's we just kind of unwrap it and rewrap it to get those values. And at the end, we just smash all the data together and then say, give me a list of all the tables, what their min and their max value is. And the important thing to realize is because it's histogram buckets, these aren't the absolute min and the absolute max. This is a rough approximation of the lower boundary and the upper boundary. So if you say, if it gets to, like 2,100,000,000, it may not get there in time for you to solve this problem. So if you're going to build like thresholds around this, that's fine. This will be quick. This takes, a few seconds to run at the most. This will be fast. So you can run this pretty often and just keep an eye on what's going on. It won't solve all the problems. I'll switch to the slide in a second. But for the most part, like this is a quick way to sort of get a scope of what's going on in a database to see whether or not, how close you are to danger. So even with that query though, right, one, it's only as good as the last analyze. So if for some reason you're not analyzing regularly, then that's unfortunate, and you probably should fix that problem too. But these numbers could be stale, so make sure you're analyzing regular enough to think, to keep up with your rate of change in the system. Watch out for negative values. We'll talk a little bit more about that in a second. It won't break the query, like it does work with queries, but it'll look a little bit weirder. And it still might not protect you from artificial escalation, right? If like one day you're at 900 million and then the next day you happen to be at 1.9 billion because of some architectural decision, not because you've actually put that many rows in, like you'll be running out of space much sooner than you thought you would be, right? So it helps to kind of run this regularly as part of monitoring, maybe not every 5 minutes or whatever, but once a day or something along those lines. Yes, sir.
That query's not part of check Postgres script yet?
It is not.
Have you asked maybe kind of cool to add it?
I have not.
Okay.
So it could probably be added. So I thought about submitting a patch, honestly, but then I was going to have to write Perl. And I actually like Perl, and I just didn't want to write it. But would not be bad to add that to that. We've written it for other monitoring systems. So yeah, if you have the ability to do it SQL, I mean, you could do it as an ad hoc SQL and check Postgres, right? You probably have to return different values, because this is sort of printing a report of what's going on, and you probably would need to format it based on what you're feeding that into. But that's definitely something that could be done. All right, so let's say you get into the problem, you have the monitoring or whatever, maybe you do, maybe you don't. All of a sudden, one day you show up at work and they're like, hey, integer out of range, I gotta deal with that. And you're like, oh, sweet, I like a challenge. So the fastest way, if you actually do run into this problem in production and you need a solution like right here and now, probably this is the best fix for you at that absolute minute, which is, and I mentioned we were gonna foreshadow this idea that you can actually use negative values in the sequences. So the actual range of these data types, right, for integer is like negative 2.1 billion to positive 2.1 billion. But when you use it with sequences, it generally starts at 1 and counts upward, right? We don't start it at negative. So if you have to, you can flip your sequence to work from the negative key space and work its way back to 0, right? And so that's, a couple of commands. Yeah, so at sequence is whatever your sequence is that's involved with the table. You change the min value to be negative. By default, the min value is 0. So you do have to actually change the definition of the sequence first, and then just set the value to some negative number. I actually would probably do it at like a flat 2 billion so that it looks sort of more obvious that somebody has manually done this. And also, sad to say, I have at least once needed. So like when you flip this, you have 2 billion entries now, right, to fix your problem. I have actually needed that extra 150-ish, million because we didn't fix it in time, and then so we did flip it to 2.14, and then we're like, hey. So I hope you don't ever need that extra, but if you need it, then you got it, right? Now there can be issues by flipping this negative. One of the ones that comes up at first is like if you are assuming that the order of the numbers correlates to the order of, the entry, the order of date entry into the row, into the table, then that could be a problem because now your negative ones are actually newer than your positive ones. So hopefully you don't do things like that. So here's a few examples, and again, I'll walk you through some of these. And these are sort of like other emergency tricks you can use. So if you do the negative thing, or maybe you can't do that, and you have to do something else, there are ways to start attacking the problem as a way to actually fix it long term, right? So in this case, so imagine you've been a MongoDB DBA for a long time, and now you're working on Postgres. So you have your table, and it's 2 columns. The first one you say, give me a Y serial and a Z JSON B. I'm going to put all my data in that. Obviously, that's a joke, because if you're a MongoDB DBA, that would have been a Uuid, but we're not talking about that. So, all right. So one of the quick fixes is you would alter the table, just add a column like future Y, which is a big int, right? And so now you've got this extra column where you're going to start putting that data. You can alter, and then within transactions, always remember you've got transactional DDL in Postgres. It is a superpower. And so you can do all kinds of changes across different schema and make that atomic to any of your applications that are out there. That will definitely be handy in cases like this to cut down on the errors. So you start a transaction, right? We rename the table to whatever m.old, or however you want to call it. Make a view that just coalesces the big int and the int column, right? From y and future y as y, and then you got your z from mo, because we've renamed it, right? Now you will have to create a trigger, and like I said, I don't give you real code. You'll create a trigger before inserts, possibly updates or deletes, depending on what you have going on with the table, which is going to need to deal with the fact that when you start inserting values that are too big, right, they've got to go over to the big int column, not go into the integer column, right? So you'll have to do a little bit of function magic and put a trigger in place to manage where that data is going to go. But otherwise, like performance-wise, this will behave and perform pretty much like the original table. And I will say I've tested this under very high stress, so it will work and probably not be a problem. So this is like one trick, and this is doing it like within the same table, right? You can just create this extra column, do the coalesce with a view trick. Once you're done, and you've got to do backfilling right on all the old data and get all of it moved over. So all the old rows where it's in the integer column needs to be copied over. You'll probably have to vacuum. You'll probably have to learn what PG repack is, like all that good stuff. And then once you're done, like you just rename the view, and now the new version of the table gets renamed to the table name, and you drop the old column, right? And you're good to go. And again, the problem is like if you got 2 billion rows, that might take a while, and you need to figure out like when you can actually do this backfilling and all this copying of data and all that. So there's definitely logistics that have to be worked out, which is why ideally you find this, at like 1.5 billion, not at, 2 billion. There's other ways to go around this. So the other concept usually people use is like, I'll make a second table, right, that kind of mirrors what the first one looks like. So here's, again, our awesome Y serial Z JSON B. I make a future M as a separate table, not creating a new column. And I just make that a big int, right? And then I still got my JSON B. If you have a lot of columns in your tables, like you can go and clean up a lot of things if you're going this route. So if you've got columns that you added after the fact that didn't have not null constraints that you wish did, like you can add all that stuff into your future M table as needed. And again, you need triggers to sync the inserts, updates, and deletes between the two. That does depend on exactly how you're interacting with the table. If you're not ever deleting data, maybe you don't need such complicated triggers. But you sync it all back. And then again, transactional DDL to make this transparent to the apps. We alter the table, M, rename it to M old, right? And then alter the future M, rename it to M. Everybody's happy. Nobody is the wiser. I will say, again, caveats, because if you use a lot of foreign keys or you use a lot of views or other dependent objects, this all gets much more complicated, and you kind of have to work it out ahead of time. So it does depend on the schema and how complicated your schema is. If you're using partitioning, that also makes this more complicated. Or maybe you introduce partitioning in your future M table. That's also an option. But be that as it may, you've got options, and that's sort of the key thing to get across. Like there are ways to like rebuild these tables using triggers and views and whatnot to mask it from your application and shift your data around. This is another one. So this is just sort of the same example, but I just want to show one where like if it's not the primary key, right? So here we've got Y is a big serial. Maybe we did that correctly, but P is just another column in the table. Maybe we thought it, or maybe that is a foreign key, like artificially. And we picked it as an int because we thought that was going to work. Again, you can use the same trick. Just make a future table, rename the column. And in this case, I had to do this once, and I created the view, and I just joined the two tables based on Y, right? Both of those are indexed. Again, this will probably perform fine for, certainly simple queries. If you're doing primary key lookups, it'll work fine for that kind of a thing. It's 2 index scans versus 1, more or less. And then you just coalesce it to make the view look like the old table. And triggers to sync the data and all that backfilling, and actually rename your tables and views. So keep those tricks in mind, right? That views and triggers combination and using transactional DDL, you can make all of that transparent to your applications. I'll also say, right, just as a sort of bonus tip, these tricks that you can do with tables and views, you could do this with logical replication to another database or even back into your own database maybe. or with foreign data wrappers. It is a little bit more complex because now, again, you're introducing a second server, so it's a little bit harder to mask this, but it can be done. So if you want to go that route, we've done that on some where not only did we sort of rebuild the table in a new image that was better, we did that on a newer version of Postgres, so then we also had that kind of goodness to be able to take advantage of. So again, you can do that with other tools that Postgres has. Just be aware it takes more planning, right? Probably some testing to make sure it's going to work. There's one other thing I wanted to talk about, some other problems to consider. I think part of this is like we often focus on the database part of this. That is only one part of this. There's definitely other factors to keep in mind. As they used to say back in the day, let someone think of the children. And here, by children, obviously, I mean the apps, because developers are children. Just kidding, we love you. Anyone here actually, like, hardcore developer? Like, yes, I'm just kidding, I didn't mean any of that. So, like, if your app was based on some ORM schema generation tool, right, it might have looked at the schema files that are in the ORM code and said, oh, it's defined there as an integer, right? And if your DBA goes and makes these changes behind the scenes, doesn't mean they're actually updating like your Rails code or whatever, right? Like they probably are not doing that, and so that definition, like watch for drift if you're defining your schema someplace else, especially if applications are reading that and then trying to work with it. That's the most common one I've seen, but it does get worse depending on the nature of the applications you have. If you think about other languages and how they work, so one problem we've seen, and like when I say I've seen, like all of these pretty much we found the hard way. So maybe your language you're programming in uses unsigned ints, and an unsigned int, so in Postgres, we just use sign ints and big ints and whatever. If your programming language uses unsigned ints, and the developer has said, oh, these are integer values, I'm going to use an unsigned int to store that, well, their range is actually 0 to like 4.2 billion, right? So it's all positive integer space. They don't support negative integer space. Yes, the first time I ran across this problem was when I flipped a sequence to negative, and then the application broke because it didn't know how to deal with a negative value. We ended up changing that application to just take the number and convert it to text for display on the screen, because that was the fastest thing we could think of to get that working. Oh my, indeed. So watch out for that, right? The other thing that we've done, and this one, again, maybe we found this in production, we switched it to BigInt. We thought all our problems were solved, and then 9 months later, suddenly we were getting errors in the application because it was trying to use like 4.3-ish billion as a value, which was fine in the database. It was inserting that all day long, and then when it was trying to read it back out, it couldn't because the app thought it had an unsigned int, and it could no longer understand the value. It was just too big, right? So we needed to convert the app again there to understand we're now going to use big ints. So yay, fun with data types. And that is different, just depending on what languages you're in. If you're using like PHP or something, like, just throw the ball in nails, it'll probably handle it. It'll be fine. The more you get into like strongly typed data types where they really care about what the values are, the more likely you are to hit some problem like this. The other thing, again, complexity of apps is always an issue. So modern systems being like ogres, they have lots of layers. If your applications talk to an API, which talks to your database, or there's some kind of translation layer in there, you kind of have to follow the chain all the way around. If you've published an API spec that says this returns integers, like people may have built applications based on your API thinking they're going to get integer values, and now you've had to make that change to something else. Things can go wrong really quickly. If you're compiling that app and have to distribute it, like maybe you have a mobile app on your phone that allows you to interact as a customer, and so then you realize I have a big int problem, which means I actually have to change the app code and recompile it and resubmit it to the App Store, and Apple is very good if you tell them, oh, I had a big int key space issue, I need this to get authorized right away and download it to everybody. Can you just force it out? Like, can you just upload it now and force it to everybody? Yeah, they'll do that for you. Again, if you can catch it early, it is definitely best to catch it early. You don't want to have to deal with it last minute if you don't have to. One more piece of code before we wrap things up here. So I also want to give you this idea that like we tend to also think the default value setup in Postgres is very static. People don't think about this, but we are just calling a function in most cases. If you have a sequence that's there, it's like next val on the sequence name. But you can replace that with any default you want. So one of the things that we started to do when we know we were going to do these like large transitions, and in our case, in some of the production systems, like it's not like there's one app. There are so many apps and so many downstream places that it could go. Sadly, nobody actually really knows where the data ends up. Pretty sure there's a manhole cover out on Bowery that, like, if you look in there, like, you're going to find some data that we shipped over there. So what we do, it's not all that complicated. You just create a little function like this. So this is just like generate primary key ID, and there's a lot of different ways you could do this. It's just sort of one example. So basically, I'm just going to generate like a random number, right, from 1 to 100. And then I'm going to look at that number and say, hey, and you can sort of modify this piece here, this per mil equals 100, to be however many you want it to be, right? So if you want to send like 1 or 2 through the system, keep that really small. If you want to do like 10% of your traffic, something like that, I recommend keeping it very small. So like, 1% or less as you're doing this testing. So then here I'm just returning from what would normally be the normal primary key ID sequence. Right? Actually, this is actually the opposite way. Oh boy, this is good code. This will mess up your database. So this is actually like the 99% version, not the 1% version. I told you, don't trust my code. That's awesome. So in theory, this should be the other way around. So you would do the normal primary key, maybe down here, and the experimental one up here. But in any case, whichever way you want to bifurcate that, like you can. And then on the experimental one, right, you just make a different sequence because they're pretty fungible. So like what we would do is we would send both, big int number values. So we'll create a different sequence that can support big ints, and then we set a number up there, super high to over 2 billion, sometimes like 5 billion, because then we know we can find the unsigned int problem if that happens. Then we'll reset it to like a negative number and send a few negatives through the system. And then if you want to shut this off, it's really easy. It doesn't actually require DDL. You just recompile the function and change this to something like greater than 100, because it's never going to generate that. Which, again, in this case, would make it permanently on the experiment, because the code is backwards. Don't use this code. Yes, sir? Because of the times 100.
I'm saying the random itself is 0. It's always less than 1, though, right?
It'll be it'll be never 0, I think. Bruce wants to answer this question.
We don't round up on an integer truncation. So unless it amazingly ends up being 100, which would be really, even 99.9999 is going to integer to 99.
Maybe it's because of the float that I put in there.
I don't think
that will definitely end up as 100.
It will, okay.
Yeah, for sure. So, but again, you're asking the question like you're going to actually use this code, and I'm a little bit concerned for you, sir. You understand the idea here, correct? Okay, so then you should write the code correctly instead of having my code be used. You could. It's like, this is not a large, this is a venti, right? Like, just because it says one thing doesn't mean what it is. By the way, I do apologize to all of you who live in New York. I do have a rule. I generally never buy Starbucks in New York because you got better options. But I was running late for the talk, so I had to sacrifice some ideals you can't be as pure about. But I am pure about don't use my code. Clearly, there's like 4 bugs in here already, and this is about the simplest thing you could write. So, but anyways, like look at the idea that's there, right? Like once you put this extra function in place, you can change this to be whatever you want. You can go back to the regular default once you're done with your experiments. And you can, to the degree you have the ability to be flexible, you can look at values that are coming in. So if like you've got, an employee column or something where these are internal users or something, you could say, well, if the new thing is employee, is true, then go ahead and send it these fake values or whatever, right? So you can kind of do that just to like push some data through the system. And keep that in mind. And again, this assumes you've got time to actually work on the problem correctly. You may not, but if you have found it, like this kind of a trick is really useful. Because I will also say, developers being super awesome, often they write code like I write code, so they don't know whether or not. If you ask them, is it an unsigned type or not? Like, what's the max value? Like, they don't know. So that's fine. Like, systems are hard. Code is not always easy. So that's probably the best way is like just send some test values through the system, make sure that it's actually gonna work. So that's all I really want to talk about. I wanted to give a shout out to Rhodium Toad, Alessandro and Vasilis. If they watch this, they know who they are. Maybe you know who some of them, or some of you know who they are, who have helped with bits of this at times. So thanks to them. But otherwise, thank you all for coming. And I think I might have a minute or two for questions. He says I do. Or you can be the first person in line at lunch. I don't know what you prefer, but I like to give options. Sounds like lunch. No? Oh, Bruce.
You were right about the answer. Floating, we round up. I didn't realize that.
There you go.
Yeah, you're right.
That's the one part of this I tested, was that 100 thing. Because I was trying to remember that, to be honest. That's why I knew, because I just tested it last night. So all the other stuff, clearly I did not test. That's from the bad notes. But that one I did. So, okay. Anything else? We're good? All right. I will see you all later in the day.
Awesome, thank you.
Thank you.